doing well and all your family members also keeping safe. So
Yes,
in
sir.
the last class, oh, thank you, good. So in the last class, we have mentioned about different diagrams and their importance. And one of the complex diagram is PNI diagram, that is piping and instrumentation diagram, where you can actually get different symbols and also you get idea about the process lines, like whether you need to use a specific material for a specific flow path or process line, and whether you need to have insulation or you need to have um, uncovered area, lined area, internal lining, external lining. All these details will be there in the PNI diagram. And also you will have a lot of details to operate different equipment or process units when you talk about automation, because within your process system will have a lot of valves and also different other operational unit which will be controlled by different PLC, programmable logic control units, where some specific commands will be given based on monitoring different parameters. Suppose you need to adjust the pH. So in all process operation, very rarely you will have manual intervention to adjust pH. You will have pH meter, so pH meter will just sense the pH, and based on its sensing, it will send the signal to the control unit. Control unit will judge the signal and whether it will check whether it is maintained at the set pH. If it is maintained, then it will not send any action. But if it is not maintained, suppose the reactor to be maintained at neutral pH, but due to some reaction, suppose pH shows in that particular reactor is about 8 pH. Now the control unit will compare the value with the set value. So set value is your desired pH, that is neutral pH. So whenever it will compare with the set value, then it will sense whether it has to activate alkali dosing pump or acid dosing pump. So whenever pH is more than neutral pH, then it will try to neutralize. So it will start adding acid. And whenever it will sense lower pH than the neutral level, then it will start adding certain amount of alkali, and then again monitor the pH to check whether it is actually maintained at neutral level. Similarly, for temperature monitoring or temperature control, you will have, so you can see in the picture there is a diagram for heat exchanger. So whenever it will try to maintain temperature in a specific system, it will maintain the flow rate as well as temperature in the process flow line to get desired temperature in your actual operation. So whenever it will sense the temperature is actually going above the set value, then it will try to reduce the flow rate of the hot liquid, or it will try to activate the cold liquid line to reduce the temperature. And if it is required to raise the temperature, then it will just activate the opposite action. So all these operations are actually done by the programmable logic control unit. So you are not getting any manual intervention. You will get mostly automatic system management. And for doing that automation, this piping and instrumentation diagram is very, very important. So for any engineer, it will be very easy to identify the role of individual unit and also kind of control systems required to make the system automatic. Now, if I give an example of the first diagram, say it is actually strictly not following any of this convention, but it is, if you see the penicillin production scheme, we know that the objective is to produce 1 lakh liter per day, and to start with the production, you just use the dried spores preserve in test tube. So you preserve in the vial, then you grow them in test tube, prepare slant culture. So you start with very small amount and then finally you try to get 1 lakh liter. So the entire process is actually shown in the production process. I'm not talking about the purification and preparation of other raw material. So this production of biomass will require multiple stage. So here it is just showing the kind of reactor we require to enhance the production capacity. So it is somewhat similar to block diagram because although it is showing the image of reactor or the symbol of reactor, but it is actually not giving very good idea about the input output values. So whether you need certain amount of mass in the first reactor and what kind of mass we require in the second reactor, those amounts are not mentioning here. So although you get some pictorial view of the reactor, but it is still representing the block diagram feature because you are not getting any other information from this system. So you can see in the production unit, this biomass concentration to be increased, and then finally absolute biomass value should be made in such a way that you can get this till 1 lakh liter slurry where you get substantial amount of biomass. So in any process, this particular section is actually called the heart of the process because here you are producing your desired material and after production. So if you see this, first you grow the culture and penicillin is again one kind of secondary metabolite. So after growing the culture, you get after growing the cultural slant, you just transfer it to the sex flask. So the volume of sex flask is say about 500 ml. Then you transfer it to 1 liter reactor. Then you have 10-liter reactor. Then you have 100-liter reactor. And most of the cases, when you grow the aerobic culture, you always try to maintain 10% as inoculum. So when you use this shake flask, so after growing the bacterium, this fungal spore in the shake flask, suppose you are getting 500 ml volume, and this is a 1 liter reactor. So when you try to start operating 1 liter reactor, you need to maintain or you need to start with 10% inoculum, 10 to 20% inoculum. But in aerobic system, mostly we drill with 10% inoculum. Now to get 10% inoculum, you need to add 100 ml. If your final working volume is 1 liter, 10% of 1 liter is 100 ml. So from 500 ml liquid, you transfer 100 ml and then do this operation. In the second reactor, again, the entire volume will go to the second reactor because your working volume is 10 liter. So you need 1 liter here. So the entire reactor volume will go there. And then from 10 to 100, again 10% you will add. So in this manner, you will try to increase the capacity. So whatever you are preparing in the previous reactor is actually being used as inoculum to the next reactor. And we are we're calling it as heart of the process because in this reactor system, we're actually doing the production. And before going to reactor system, we actually use multiple units for processing the substrate or for generating the inoculum. So essentially, when you talk about your actual bioprocess system, there all these stages means till the production fermenter. All these stages before the production fermenter will actually not come under this production unit. So typically for any bioprocess system, you will have upstream, then you'll have process, and then you have downstream. So upstream and downstream, they are actually just before and after the production process. So heart of this particular bioprocess system is your production process. And before production, you need to prepare the system, like you need to acquire substrate, you need to prepare the reactor, you need to maintain the sterility in the reactor. And before adding all the feed substrate as well as other reactor in the reactor, you need to clean them, you need to maybe you need to reduce the size, we need to add certain additives. So all this step before the production fermenter is actually belong to this upstream processes. And in production process, you will actually have mostly the production process will consist of the main reactor or fermenter where you will produce the material. And after getting this produced biomass or any other um, byproduct, it will actually go to downstream unit. So downstream unit is also not consists of only one particular process. You may have multiple processes, and most of the cases you will have quite good similarity of equipment used in downstream and upstream. Although their motive will be different, like in down upstream, you are trying to use some system to wash the ingredients. Now in downstream also you will use some system to wash the final bioproduct, but their target material will be different. So operation wise, they are very similar, but the target material will be different. So you will find upstream process and downstream process will have a lot of similarity in terms of machinery they use, but their motive will be different. So for any process, whether it is chemical or biochemical process, there are the three prominent sections you could see. One is upstream unit or upstream processes, and then you will have production processes, and then you will have downstream processes. Now, when you talk about unit will always talk about a simple system or a single system. But when you talk about processes or process, they actually have combination of multiple units. So production process can be defined as production unit because you'll be mostly dealing with one particular reactor. Whereas upstream and downstream there, they are not actually consist of only one particular machinery or one particular system. You will have combination of multiple units. That's why instead of calling them an upstream unit or downstream unit, you call them as upstream process and downstream processes. And production process can be defined as production unit. And when you do all this kind of uh, means when you try to define all these processes or units, there you will find some specific chemical uh, conventions. Like if you have excess reactant, then you'll try to recycle the reactant back to the system to get maximum utilization. If you have um, inhibition caused by some certain reactant, then you need to bleed the reactant, means you need to purge the reactant or discharge the reactant. So either you can have recycle or you can have bypass line. So these are common scheme applicable to all three setups, like downstream processing, upstream processing, as well as production processes. Everywhere you can actually get this kind of setup. You can either have bypass or you can have recycle of various streams. Similarly, particularly for upstream and downstream operation, you can have filtration, centrifugation for separation. So if you have mixture of different component in your raw material and you need to just concentrate a specific component, then you can use filtration based on their size. So filtration is actually a mechanical separation based on their size, and centrifugation again based on their density size. You can separate them with the help of external centrifugal force. So filtration is due to gravity and size, whereas centrifugation is actually the induced gravity or external force you use to separate in a faster way. So this process or this particular operation is available in upstream processes as well as downstream processes. Now, when you check each of the unit, like in upstream or downstream processes, if you just check each of the unit, you actually need to do mass balance, energy balance across the unit. Means if you have certain things going into the system and coming out from the system, then you will try to do the balancing and check what kind of product you are getting from that particular unit. So whether you are that product may not be the final product, maybe that product could be an intermediate material for the next process or next reactor. But when you do this mass balance calculation, they will actually see the efficiency of each and every unit. Like if your target is to get 80% separation of certain component present in the raw material, and in one particular filter system, you could get maximum 30% efficiency, then it will actually allow you to design how many such units are required and what kind of arrangement would be there to get better efficiency or better utilization of this kind of processes, whether it is in upstream or in downstream operation. Similarly, dryer is also one kind of unit or one kind of unit operation or system which will help you to remove moisture or separate liquid from solid. So in bioprocesses, you will have little bit of difference from chemical processes, because in bioprocess mostly we'll deal with heat sensitive material. So in chemical process, wherever you use dryer, you could easily use um, temperature as a driving force to just increase evaporation material. Whereas in temperature sensitive material, you try to reduce the boiling point, and to reduce the boiling point, you just create low pressure region. So you can do that drying operation at a low pressure. So generally, most of the cases we use for biological substances, we use freeze dryer. So at low temperature and low pressure, we try to have elevated boiling point, and using that boiling point elevation principle, we just try to uh, we just try to remove the moisture from the system. Extraction is also one of the common unit used in upstream and downstream process, where you add certain amount of solvent, because different solvent will show different kind of affinity towards different component. So generally, a thumb rule is used, like dissolve like if you have polar compound, then polar solvent will actually help you to remove it from the mixture. Similarly, if you have non-polar material, then you also use non-polar solvent to remove that from the system. So in upstream or downstream, in upstream, it is actually to concentrate certain things which will be used in a production unit, and downstream is actually to concentrate certain things which are already been produced by the production unit, and you are trying to purify the product. That's why you're using this extraction. So in extraction, again, you check the efficiency, and also you need to do the mass balance to check how much solvent you require to extract certain amount of component. So here, distribution coefficient of that particular material in different solvent is also very much important. So when you try to design this extraction unit, you also make sure that the distribution coefficient and also or partition coefficient are considered, and also the kind of solvent you require to improve the extraction efficiency should be considered. And also you need to make sure that the kind of material you use, that should not have any adverse effect in the product quality. Suppose you are using certain organic solvent which are carcinogenic in nature, and the final product is some food product where the system will not, or where the regulatory norms will not allow you to have minimal presence of any carcinogenic compound. So obviously you will not, even if you get really very good efficiency in extraction, still you will not be able to allow, you will not be able to allow to use that kind of solvent to do the extraction operation. So you can have single stage extraction unit, you can have multi-stage extraction unit. Now based on your efficiency, extraction efficiency, you will decide what kind of extraction system you need to use, and also the sequence. Suppose in the first extractor, we are trying to remove most of the aqueous system, aqueous or water soluble material. Now you use a solvent which will try to remove those uh, hydrophilic components. And now in the second extractor, it is very much possible that you are trying to remove most of the hydrophilic component. So there also you will use a desired solvent. So you can have multiple extraction unit, and their solvent could be varied. Depending upon your requirement, you can actually vary the solvent, and then finally you try to see the product quality and quantity after the final extraction unit. Now another unit is also very common for this liquid means either gas or liquid separation, or a liquid and liquid separation also, like two different gases are there. So fluid separation means gas separation, or gas liquid separation can be done using absorption unit. So you have column packed with certain adsorbent, and these adsorbents are very specific to certain compound. So when you put the mixture of compound, a solution to the system, the adsorbent will show specific affinity towards a specific component, and because of their interaction, one component will get adsorbed and other component will actually leave the reactor. So you essentially you're doing separation, but with the help of adsorption unit. And then finally, to dissolve that particular component, you either manipulate the operating conditions, like by raising temperature, changing pressure, or by adding some other external solution to remove them from the adsorbent and regenerate the adsorbent surface. So this adsorption unit is also used in purification stage, that is downstream process, or upstream process, wherever you need to separate two different fluids, or fluid means, yeah, means whether gas separation or gas liquid separation. Now, in as I told you, downstream operation and upstream operation, there mostly you'll deal with multiple units. So all this process, whatever I have mentioned before, like adsorption unit, extraction, centrifugation, filtration, all these operations are called unit operations. Now, when you use Then you mostly deal with combination of multiple unit operations. So you may have extraction followed by centrifugation or followed by adsorption or maybe filtration, then centrifugation, then extraction, then adsorption. So multiple unit operation could be there, and that combination will actually give you the entire upstream or downstream process. So one of the common thing used in almost all the processes is to procuring the raw material. That is also come under upstream process because obviously, suppose you need to buy some natural resources like wheat straw or rice straw from a farmer. Now, if you have your unit or your the production unit in a city which is quite away from the village or any other farming land, so obviously, if you don't have the agricultural activity near your industry, you need to rely on specific transportation process. So all this transportation mechanism and their associated cost will actually get added to this upstream process. So procurement of the raw material, if it is done from a different sector, then that process with procurement will actually come under upstream processing. Now, after bringing that to the industry premises, you will actually do the real upstream work, that is purification. Like if you get a lot of other so with wheat straw, rice straw, now you need to have some sort of separation. That separation could be based on the and you may need to go for washing. You will just wash different kind of washer. You can have mechanical washing, you can have washing combined with strainer. So different unit operation would be there based on the requirement of that particular system. And then after washing, you will just maybe if you need to dry them, you will have either sun drying system or you can have accelerated drying system by providing hot air. In some cases, you will see deliberately will be using some gases which are which also has some disinfection properties like sulfur dioxide. Deliberately, we will use some sulfur dioxide in the system to prevent spoilage of the material. So, and then we will do the further size reduction or separation. And then finally, after getting the desired quality of raw material, you will put it to the production unit. That is your reactor. So then you will do the reaction of fermentation. And after fermentation, whatever product you will get using similar manner means obviously, as I told you, motive will be different, but unit operation will be very similar. Suppose after getting the solid liquid slurry, like you will get biomass in the aqueous solution. Now, if you are interested only on the biomass, then you will try to separate the slurry from the reactor. And then if you feel that the reactor liquid still has some substrate which can be utilized, so you will separate it using either settler or centrifuge, continuous centrifuge or filter, and then recycle back the residual liquid to the reactor to get a little bit higher productivity or higher utilization of the substrate. And whatever biomass you are getting from the settler or filter or centrifugation system, that you will use in subsequent units. Suppose you need to wash it. Suppose whatever filter cake you get or whatever cake you get after centrifugation is still containing certain amount of residual substrate or other component present in the reactor. And if it is not desired in subsequent process, then you will wash it. And after washing, again, you try to remove the moisture. So after removing moisture, if you need to get them in a specific form, then you will use different kind of shredder unit, or you can actually use different processing unit. Like if you need to crystallize the material, then you will use a different kind of crystallizer. If you need to distillate the material to get certain component, you will distillate the material. So after obtaining the biomass, you can still have a lot of other processes to follow to get material. After getting the to sell well, material, purification could be very, very expensive. So in the entire process, maybe the production is not that expensive, but the purification is quite expensive. So product cost will actually have substantial component in the downstream operation. And it is very true with most of the pharmaceutical production. So categorically, we call them low volume, high value product formation. Like in pharmaceutical industry, certain components are produced at very, very low volume. You don't need to produce 1 ton or 1 lakh liter per day. Even if you produce 1 kg, it will have significant impact. So low volume but high value product will actually rely on very expensive downstream operation. And in production process also, we take certain care to make sure contamination free environment is maintained to avoid getting more contamination in the product. Because whenever you have increase in contaminant in the product, you will actually require more expensive downstream operation. So motive will be different, but similar kind of setup we'll use in upstream and downstream operation. Now I mentioned about core of the production process is actually your or heart of the production process is your bioreactor. Can you see the bioreactor on the screen?
Not yet.
Oh.
Yes, sir, we can see the bioreactor now.
Thank you. Thank you. I think it is working now. Okay. So the central unit is your bioreactor, or heart of the production process is bioreactor. So I'll just spend a little bit of time to discuss about different unit or different component of the bioreactor. So you can see the central vessel. So in the central vessel, this vessel could be of glass, stainless steel, or sometimes we actually use wood, some specialized wood material. So especially for brewery industry, when we try to produce alcohol, there we use different kind of woods which actually impart certain um, fragrance or taste to the liquid. So we use wood material or glass material or stainless steel material, and sometimes even in stainless steel material you can have inner glass lining. So you will have bigger stainless steel vessel because stainless steel will actually have higher provide you higher material strength. Now inside of that vessel will have glass lining to prevent any undesired reaction between the liquid component with the reactor material. Now, inside the reactor, you can have spurger at the bottom. You can see at the bottom there is a circular disc having multiple holes. So that is one kind of design of spurger. You can have jet spurger. You can have membrane even. You can have one of the closest example you can visualize is your aquarium ear stone. So it will be similar to aquarium ear stone. You can have ceramic perforated membrane. You can have polymeric membrane as the for creating very tiny bubbles. And also just above the agitator or above the spurger, you will have this central shaft having impellers. So impeller is also one of the important component in the reactor to accelerate transfer processes like mass transfer, heat transfer. So just to maintain homogeneity in the reactor system, both the units, this both the component, spurger as well as agitator or stirrer, plays crucial role. And then the in the body you can also have some jacket to maintain temperature in the reactor system. So you can see it is showing cooling jacket. Cooling jacket is actually the jacket surrounding the reactor vessel or reactor wall. Now, through this jacket, either you can supply cold water, or sometimes just to maintain temperature, raise the temperature, you can supply hot water. Depending upon your requirement, you can have that arrangement. And sometimes inside the reactor, you can have heating probes. So if you need to raise the temperature inside, you can have a heating probe. So instead of having the jacketed vessel, you can have a vessel and inside you will have heating probe to raise the temperature. Now, for maintaining desired temperature, this cold water line or hot water line, they will have a specific control system to maintain their flow rate, to maintain kind of liquid is required. Liquid to be used in this particular systems are also being advised by different engineer because you are not allowed to use any water or any other liquid. Suppose if you need to maintain long operation condition and also to certain level of temperature, then you use specific coolant or maybe specific material to maintain the temperature. Now, you can see one particular tube is coming as sampling line. So it is from the almost from the bottom, just above the spurger, you will have a tube which is coming as sampling line. So most of the cases in the fermenter, you periodically take the sample and check the level of a reaction. So whether it is actually almost done or whether it's still you need to wait for certain period and whether you are getting any undesired product formation. So for that, to periodically collect sample from the sampling line and check the consistency of the product and also quality of the product. Now, biological system will require sterilization, because initially when you add all your substrate and before adding the inocula, you have to make sure that you are not getting any other undesired organism growing inside the reactor. So to sterilize the reactor, you first put ingredients which are not temperature sensitive, and then after putting all ingredients in the reactor, you can see at the bottom of the reactor there is a line called steam line. So you just inject certain amount of lean inside, and at high temperature, at elevated pressure, you maintain the reactor say at 121 degrees centigrade for at 15 psi for 20 minutes, and then after doing this operation sterilization, you get some confidence that the biomass concentration or impurity concentration inside the system is negligible or almost zero. Then you add your inoculum, but immediately after doing this sterilization, you don't add the inoculum. You just wait for get the temperature to a suitable uh, value, because the biomass are temperature sensitive and you are doing the sterilization operation at above boiling point of water. So you try to wait to reduce the temperature to a certain level where the inoculum will not get destroyed, and then to add the inoculum and start operating the reactor system. And when you try to adjust, when you try to add the air, you need to maintain sterility. That's why you could see a box at the right hand side. There is written air filter. So whatever air you will supply, that air stream should get filtered through the air filter. And sometime, if you need to maintain a specific air temperature, you can have a heat exchanger before supplying the air. So you just either reduce the air temperature or elevate the air temperature by using a heating or system in the air supply. After the filter, it goes to the now continuously to supply air. You have to have some so air it will again go up for because so you get to escape. So at the outlet also, as a precautionary measure, in most of the industry they also put a filter for two different reasons. One is it will not allow any other contaminant to go in, and similarly it will restrict all the biomass or other particles which are produced in the reactor to stay within the filter. It will not contaminate the outside environment also. So in the head plate, you can see different other options are there, like acid based reservoir. There actually you have control unit to monitor pH. So you can say just next to the motor and shaft, you have pH control unit. So it will monitor pH, and then based on requirement, it will actually activate acid or alkali dosing pump to add maintain pH. Similarly, at the top you have DO monitor the oxygen concentration in the liquid. As I mentioned, oxygen concentration can be enhanced by supplying more oxygen or by mixing the stirrer to dissolve more oxygen in the liquid. So based on the requirement, it will actually have a cascade signal. So a combination of action can be activated by controller. Either it will increase the flow rate of oxygen, or it will increase little bit and also increase the rotational speed to enhance the oxygen concentration. But in all reactors, they will have certain limit for temperature variation and rotational speed, because these materials are temperature sensitive and also they're shear sensitive. Means if you create excessive amount of shear, the bacterial cell will actually get disrupted, and due to cell disruption, entire process will fail. So you have certain upper limit to get mixing mediated by the stirrer movement, and similarly When you supply more amount of oxygen, gas holdup will increase. Amount of gas present in the liquid in the reactor system will increase. And if you have really very excess amount of air or gas, then you will have flooding of the reactor. And it is very much possible that it will actually push all the liquid to the outlet and you will have excessive loss. So you have to monitor all this parameter and then you have to keep all other operation parameter within the limit to avoid any failure of the reactor. Similarly, in the top, you can have multiple inlet to add certain component which cannot be sterilized at the beginning. As I mentioned, if you try to add some vitamins or some other component which will actually get precipitated if you just raise the temperature, and they will actually have different kind of dissociation reaction. So to avoid dissociating all these components or avoid dissociation of all these components, you actually add them using some filter, and then you add them to the inlet line. So multiple sample addition line would be there on the top. So typically on the head plate you can have this stirrer shaft hole, and generally in the stirrer shaft hole you will use some mechanical seal to avoid any leakage of gases. So outside gas should not enter the reactor. So although it is not shown here, but you will have mechanical seal. And on the top you will have motor shaft. On the top of the motor shaft you will have the motor drive to rotate the stirrer. And again the motor drive is actually controlled by the control unit to provide certain rotational movement to get good mixing. And at the bottom, you will have like just where you have the stem line, just below that you have harvest line. That means after finishing of the process, you can drain the entire product solution and then send it to the downstream operation unit. And almost all the reactor, either on the top head plate or the side, you will have some glass plate to observe. Means visually you can see the transformation of raw material or reactant in the system. And if you see you have to rely on some certain visual indicator, then you can just use that to judge the situation inside the reactor system. And for tall reactor and very large scale production unit, we try to have the motor drive at the bottom instead of the top, because whenever you use this long motor shaft, you can see the liquid level could be occupy maybe 80%, 50% to 80% of the total reactor volume. So after having the liquid level on the 80% volume, if you need to, if you feel that the upper section means above the liquid level, the headspace area, the shaft rod is actually not making any help because you don't need any mixing or impeller in that headspace region. So whatever weight and torque required to maintain the shaft and the top mounted stair system will be essentially utilize certain amount of energy which is actually not required because you don't need any mixing on the headspace area. So to avoid getting that, for very large diameter reactor and tall reactor, you can actually mount the motor at the bottom of the reactor. So if you have bottom mounting reactor, the motor drive is mounted at the bottom, then you can easily remove the excess amount of shaft length, which is actually present in the headspace area. And whenever you remove that length, automatically weight of stirrer will also get reduced. So to rotate the stirrer, you will require less amount of power. So for power consumption perspective, and also to avoid dead extra shaft length, for large reactor, we prefer to use bottom mounted stirrer or bottom mounted motor drive. And different kind of reactors you can see in different processes, some reactor would be very simple, like a polythene bag. Like if you need to harvest a lot of algae, then instead of having all this complex reactor system, even if you can give like a transparent polythene where you just put your media and biomass, then system with certain amount of carbon dioxide or any other gases required for the growth. So there, and also you can have very simple reactor system based on. Now you can have very large scale reactor system like this complex reactor system may have volume of 500 ml to 10,000 liter or maybe uh, 1 lakh liter. Whereas in certain cases you may deal with large volume of water where the volume of this reactor would be 1 billion liter. So depending upon your requirement, most of the cases when you talk about this very large volume reactor, those kind of reactors are used in wastewater treatment because amount of wastewater generated by a given city is huge. So to treat those kind of reactor wastewater, we may require really very big reactor, and the reactor volume could be of 1 billion liters. So you can have 500 ml reactor, you can have 1 billion liter reactor size also. And when you talk about operational cost or maybe the instrumentation used in the reactor system, it is very much possible that very large scale reactor may not require too much of complex instrumentation, whereas the small scale reactor system may require really very sophisticated instrumentation systems. Anybody has any question? So whatever we are discussing today, actually, this is the same thing will come actually, similar kind of scheme will come in almost all bioprocesses. So just to give brief idea about different unit and different reactor and different processes we use in different bioprocess systems. I just given an example, but now whenever we'll start discussing about a specific bioprocess, we will actually see the kind of units we use or kind of unit operation we use in the bioprocess. So in the next class, I'll discuss a bioprocess where we use biomass as our final product, and then you can actually see the use of different kind of downstream and upstream of unit operations. So if you don't have any other question, then I'll just close it here.
Sir,
and we'll again meet. Go ahead.
You talked about like we use 1 billion liter bioreactor system. So, sir, are there any examples like apart from the wastewater treatment plant?
Now that large scale reactor systems are only available in wastewater treatment plants. So in bioprocess production unit, even wastewater treatment, biological wastewater treatment is actually part of bioprocess only. So, but when you talk about pharmaceutical industry or say food industry, there they don't use that big reactor. Mostly you'll deal with maybe 1 lakh liter maximum volume. Not more than that.
Yes, sir. Okay, sir.
Okay, sir.
Okay. Okay.
Sir, do we have any book to follow? Like,
okay, maybe in the next class I'll just, or maybe in the slide I'll just add the name of the books. So these are the reference book you can follow.
yes,
Sure, sure. Mostly industrial biotechnology books you can follow. I'll just give you the name of few books, then you can see that.
Thank you, sir.
And I'll also upload the slides in the your MS Team resource folder. I think there is a folder called resources, I think, or lecture notes. I'll upload the slides there so you can actually get access. It means you can download and see the slides. Okay, then. Thank you. Stay safe. We'll meet again Friday. Oh, sorry. Friday is actually holiday. So I think we'll have Saturday I think Saturday will follow Friday timetable. So we'll meet again on Friday then. Oh, sorry, Saturday. We'll meet again on Saturday.
Good afternoon, sir.
Okay, good afternoon.